Hi there! In this clip I will show you how to draw simple Lewis structures. Concentrating on the octet rule and some basic essentials, you will be able to draw Lewis structures of simple molecules in 3 steps. More complicated molecules which need more elaborate rules are explained in my next clip. I will explain here the 3 steps with an ionic compound, magnesium chloride, and give other examples. In the first step we draw the skeleton molecule using all the atoms of the sum formula. The least electronegative element, here magnesium, is put in the center. We flank it with the 2 chlorine atoms and can go over to the second step, where we assign the valence electrons to each atom, 2 for magnesium and 7 for each chlorine atom. We realize that none of the atoms features an electron octet, so we will have to arrange the electrons in the third step. The 2 valence electrons of magnesium are transferred to the chlorine atoms, which acquire octets. The resulting magnesium ion is reduced to its L shell, containing 8 electrons as well. Substituting the negative charge symbols with dots and neglecting positive charges, we obtain this structure which fulfills all requirements. The next example is orthosilicic acid, H4SiO4. In the first step we draw the skeleton molecule in the usual way with the silicon this time as the least electronegative element in the center. We surround it with oxygen and hydrogen in this way. Hydrogen can never take a position in the center, it is always peripheric. You will have to remember that. In the second step, we assign the valence electrons, 4 for silicon, 6 for each of the oxygens, and hydrogen contributes with 1 electron each. In principle, we have finished, but in drawing lines instead of the bonding electron pairs, we will arrive in step 3 to the final structure, which looks like this. The next example will be hydrogen cyanide, HCN. In step 1 we draw the skeleton molecule with carbon as the least electronegative element in the center, flanked by nitrogen and hydrogen. In the second step we assign the valence electrons, 4 for carbon, 5 for nitrogen, and 1 for hydrogen. We see that only hydrogen is satisfied since the S shell only can take up 2 electrons. Carbon and nitrogen do not feature octets but unpaired electrons, which we will have to arrange in step 3. And that way that we pull the 2 electrons from carbon and 2 electrons from nitrogen in between these 2 atoms, creating thus a triple bond. In drawing lines, we will arrive at this final structure featuring a lone electron pair. The last example is ethene, an organic unsaturated compound. In the first step we draw the skeleton molecule with the 2 carbons in the center, surrounded by 4 hydrogens. In step 2 we assign the valence electrons, 4 for carbon, 1 for hydrogen, and we realize that 2 electrons remain without bonding. This we can arrange in step 3 and pulling them in between the carbon atoms, creating thus a double bond. In drawing lines for the bonding electron pairs, we arrive at this final structure. In the last slide, I give you a summary of the 3 steps. More on Lewis dot structures you will find in my next clip, which deals with exceptions to the octet rule. Thanks for watching. See you again.